Okay, so for this chapter, we'll just have the ion electron configurations. So the 5.7 part is a long part since we are just talking about the introduction to electron configuration. So this will be just easy since it is also about electron configurations, but this time we have ions. So ions from our discussion in the earlier topics. So we have cations and anions. Cations are positively charged, anions are negatively charged. So these ions attain stability when the valence shell is fully filled. So when the valence is fully filled, or the valence shell is fully filled, then it is also with the same electron configuration with the noble gas elements. So most of the ions are from representative elements, and we will only deal with group A elements or representative elements in this part. So first, atoms from groups 1A, 2A, and 3A lose 1, 2, or 3 electrons to form positive 1, positive 2, or positive 3 ions respectively. So these positive ions have the same electron configuration as the preceding noble gas. So for example, we have sodium. Okay, sodium Na is found on group A. Therefore, group 1A or sodium atom lose 1 electron to become positive 1. So Na plus 1 or Na plus. So Na plus only has 10 electrons. So Na has 11 electrons. If it loses 1 electron, then it will only have 10 electrons. Okay, so if we try to designate 10 electrons, then we have 1s2, 2s2, 2p6. 1s2, 2s2, 2p6 corresponds to the electron configuration the same with neon. Okay, the preceding noble gas for the sodium for group 1A. The same goes to group 2A and group 3A. Next is we have this one. So atoms from group 7A, 6A, and some in 5A gain 1, 2, or 3 electrons to form negative 1, negative 2, and negative 3 ions respectively. The negative ions have the same electron configuration as the next noble gas. Okay. So this time we'll use oxygen. So oxygen is found on group 6A. So oxygen has 8 electrons. So remember, oxygen has 8 electrons. So group 6A will gain 2 electrons. So that means oxygen after gaining 2 electrons will be O2 minus. So O2 minus has 8 plus 2 electrons, so it has 10 electrons. So if we try to designate 10 electrons, so that is 1s2, 2s2, 2p6. So that is also the same with the electron configuration for neon. Okay, so this means that O2 minus electron configuration is the same with the noble gas neon. Okay, so let's have this problem. So complete the table below. Okay, with the neutral atom and then the neutral atom electron configuration in the noble gas notation, and then the ion after losing 1, 2, or 3 electrons or gaining 1, 2, or 3 electrons, and the ion electron configuration in the noble gas notation as well. So try to pause this video first and then complete this table on your own. Okay. So we have this answers. So first, we have neutral atom Se. So the neutral atom electron configuration is AR 4s2 3d10 4p4. Okay, so this belongs to group 6A. So therefore it will lose 2, or it will gain 2 electrons. So this will be Se2 minus. So this is given the ion electron configuration Kr. For barium, this is Xe 6s2 Ba2 plus. Ba2 plus is the same with the electron configuration of Xe or xenon. Bromine, Br, so this is Ar 4s2 3d10 4p5. So the ion is Br minus, so this has the ion electron configuration Kr. Rb, so this rubidium has this electron configuration Kr5s1. So 5s1 corresponds to group 1A, therefore it will lose 1 electron to be Rb+. Rb+ has the electron configuration also the same with Kr or krypton. Last, we have P or phosphorus. So the electron configuration for phosphorus is Ne3s2 3p3. So this will gain 3 electrons to become p3 minus. So the ion electron configuration for this is Ar. Okay. So that's it for this topic, ion electron configurations.